So now let's talk about geometric sequences. So here's an example of a geometric sequence. Let's say we have the numbers 3, 6, 12, 24, and so forth. Notice that there's no common difference. In an arithmetic sequence, let's say 5, 8, 11, 14, there's a common difference of 3. 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14. But in a geometric sequence, you have what is known as a common ratio. And in order to find a common ratio, you can divide the second term by the first term, or you can divide the third term by the second term. So if we take 6 and divide it by 3, we'll get a common ratio of 2. If we take 12 divided by 6, we'll get a common ratio of 2. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, which indicates it's a geometric sequence. Let's work on another example. Consider this geometric sequence. Go ahead and calculate the common ratio. So 8 divided by 2 is 4, and just to make sure, let's take the third term and divide it by the second term. 32 divided by 8 is 4. And if we take the fourth term and divide it by the third term, we should get the same answer. 128 divided by 32 is 4. If the common ratio between each successive terms is the same, then you know for certain it's a geometric series. In this lesson, we're going to focus on writing the general formula of a geometric sequence. So the first term is 4, the second will be 8, and then 16, 32, and so forth. So you need to identify the first term, which we could see as 4, and a common ratio. 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2. So the common ratio is 2. So here's the equation. It's the first term times the common ratio raised to the n minus 1 power. So all you need to do is replace a1 and r. And so this is the general equation. And let's test it out. Let's find the fourth term. We need to get 32. So 4 minus 1 is 3. 2 to the third power, 2 times 2 times 2 3 times, that's 8. And 4 times 8 is 32, which is the fourth term. Now let's try another example. Let's say if we have a decreasing geometric sequence, which looks like this. Go ahead and write the general equation. So the first term is 48. The common ratio, we could find it by taking the second term and dividing it by the first term. So 24 divided by 48 is 1/2. If we take the third term and divide it by the second, 12 divided by 24 is also 1/2. So the general equation is a of 1, which is 48, times r raised to the n minus 1. So that is the answer. Let's make sure the equation is correct. Let's prove that the fifth term is indeed 3. So 48 times 1/2 raised to the 5 minus 1. 5 minus 1 is 4. And 2 to the fourth power is 16. 1 to the fourth is just 1, so it's 1 over 16. 48 divided by 16 is 3. So let's say if we have the following geometric sequence, 2, 6, 18, and 54. Go ahead and find the value of the ninth term of this geometric sequence. So first, we need to write the equation. And to do that, we need to identify the first term, which is 2, and the common ratio. 6 divided by 2 is 3, 18 divided by 6 is 3, and so forth. So the general equation, it's the first term times the common ratio raised to the n minus 1. The first term being 2, the common ratio is 3. So now that we have the general equation, we can find the ninth term. So it's going to be 2 times 3 raised to the 9 minus 1. So 9 minus 1 is 8. So we got to figure out what 3 to the 8th power is. 3 to the 8th power is 6561 times 2. So this should be 13,122. Now let's prove it. So we know this is the first term and this is the fourth term. The next term is just going to be 54 times 3, which is 162. That's the fifth term. And then if we times it by 3 again, that's 486. That's the sixth term. Times 3, that's 1458. That's the seventh term. Times 3, that's 4374. That's the eighth term. And times it by 3 again, then we get the ninth term, which is 13,122. Try this one. So let's say if we have a decrease in geometric series, and go ahead and calculate the value of the eighth term. So the first term is 243. To find a common ratio, let's divide the second term by the first term. So 162 divided by 243. We have a fraction, and it turns out that both numbers are divisible by 3. 162 divided by 3 is 54. 243 divided by 3 is 81. And both of these numbers are divisible by 9. 54 divided by 9 is 6. 81 divided by 9 is 9. And you can divide it by 3 again, which is 2/3. So that's the common ratio. So the general equation is A1, which is 243, times R, which is 2/3, raised to the n minus 1. So now we could find the value of the eighth term. It's 243 times 2/3 raised to the 8 minus 1, which is 243 times 2/3 raised to the 7th power. 2 to the 7th power, that's equal to 128. 3 to the 7th power is 2187. So 243 times 128, that's 31,104, divided by 2187, that's equal to a fraction, which is 128 over 9. The decimal value of that fraction is 14.2 repeated. So let's confirm the answer. 72 times 2/3, that's 48. That's the fifth term. 48 times 2/3 is 32. 32 times 2/3, that's 64/3. And if we multiply 64/3 times 2/3, 64 times 2 is 128. 3 times 3 is 9. So we get that answer. Consider the following geometric series: 3 plus 6 plus 12 plus 24. How can we find the sum of the first 9 terms? The formula that we need to find the sum is S sub n is equal to the first term times 1 minus r raised to the n divided by 1 minus r. So that's the partial sum of a geometric series. So we got to find, let's see, all we need is the first term in r, and we can find the answer. The first term is 3, and the common ratio, 6 divided by 3 is 2, 12 divided by 6 is 2, and so forth. So now we can find S of 9. So that's the first term, which is 3, times 1 minus 2, raised to the 9th power, divided by 1 minus 2. So 2 to the 9th power, that's a big number, that's 512. So we have 3, 1 minus 512. 1 minus 2 is negative 1. Now 1 minus 512 is negative 511. The two negative signs will cancel, so the answer will be positive overall. So it's 3 times 511, which will give us a sum of 1,533. So that is the answer, but let's go ahead and confirm it. Let's write out the next 5 terms. We have the first term. This is the fourth term. To find the fifth term, we need to multiply 24 by the common ratio of 2. So that's 48. 48 times 2 is 96. 96 times 2 is 192. And 192 times 2, that's 384. So that's the 8th term. Let's do it one more time. 384 times 2 is 768. So let's add the 9 numbers that we see here. So 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192 plus 384 plus 768. This will give you the same answer of 1,533. Let's try another example. So let's say if we have the geometric sum 128 plus 64 plus 32 and so forth. Let's find the sum of the first 8 terms. So the first term is 128. The common ratio, 64 divided by 128, that is equal to 1/2. If you multiply 64 by 1/2, you're going to get the next term, which is 32. So now we could find the sum. So here's the equation, and let's plug in the data. So S of 8 is going to be equal to the first term, which is 128, and then R is 1/2. We need to raise that to the 8th power and divide it by 1 minus R. So 1 minus 0.5 raised to the 8th power, that is equal to a fraction 255 over 256. And you could divide that and turn that into a decimal, which is like 0.99609,375. Let's multiply that by 128, which is 127.5. 1 minus 1/2 is basically 1/2. So 127.5 divided by 0.5 is 255. So that is the answer. But now let's go ahead and confirm it. So the first number is 128, the second is 64, the next is 32. So this is the first term, this is the third. We need to get up to the 8th term. Half of 32 is 16, half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1. So this is the 6th term, this is the 8th term, and we just got to add the first 8 numbers. So 128 plus 64, that's 192, plus 32 plus 16 plus 8, that's 248 so far, plus 4 plus 2 plus 1 will give us the same answer of 255. So that's the sum of the first 8 terms of this geometric series. Now let's say if we have an infinite geometric series and we wish to find a sum of all the numbers to infinity. Can we do it? You need to find out if it's going to converge or if it's going to diverge. If the absolute value of the numbers are getting smaller, then yes, it's going to converge, which means that the sum of the infinite series does exist. So first, let's find R. If we take the second term and divide it by the first term, we can see that R is 1/2. If the absolute value of R, if it's less than 1, this series will converge, which means that there is a sum. If it's greater than 1, or even equal to 1, it will diverge, and you can't find a sum. To find a sum of an infinite geometric series, it's equal to the first term divided by 1 minus R. The first term is 24, and R is 1/2. 1 minus 1/2 is 1/2. So if we multiply the top and bottom by 2, 1/2 times 2 is 1, 24 times 2 is 48. So the sum of this particular series is 48. Now let's try another example. Here's another geometric series. The first term is 5. Will this series converge or diverge? Since the numbers are increasing, that means R is bigger than 1. If we solve for R by taking the second term and dividing by the first, 10 over 5 is 2. Because R is greater than 1, the series diverges, which means that we cannot find a sum. Let's try one more example. Negative 128 plus negative 96 plus negative 72, and so forth. Will this series converge or diverge? If we ignore the negative sign, if we focus on 128, 96, and 72, the absolute value of these numbers is decreasing, which means that the series converges. Let's calculate R. we know the first term is negative 128. R is going to be the second term divided by the first term. So let's reduce 96 and 128. We can divide both numbers by 2. So this is negative 48 over negative 64. And both numbers are divisible by 16. The two negative numbers will cancel. So this is going to be 3 over 4. So that's the common ratio. So now we could find the sum. Because R is less than 1, 3/4 is less than 1, we know the series will converge. So the sum exists. So we can use this formula. A1 is negative 128. R is 3/4. 1 minus 3/4. 1 is like 4 over 4 minus 3 over 4. That's 1 over 4. And if we multiply the top and bottom by 4, it's equal to negative 128 times 4, which is negative 512. That's the answer. Consider the two numbers 4 and 16. What is the arithmetic mean of 4 and 16? To calculate the arithmetic mean, let's represent it by A. It's simply the sum of the two numbers divided by 2. And to calculate the geometric mean, let's call it G, it's simply the square root of the product of A and B. So the arithmetic mean is going to be 4 plus 16 divided by 2. 4 plus 16 is 20. 20 divided by 2 is 10. So that's the arithmetic mean of 4 and 16. Now the geometric mean is going to be the square root of the product. So first let's multiply 4 times 16, which is 64. And the square root of 64 is 8. So 8 is the geometric mean. Now what exactly is the arithmetic mean, and what is the geometric mean? Like, what does it mean relative to an arithmetic sequence or a geometric sequence? So let's say if we have the geometric, let's start with an arithmetic sequence. Let's say it's 2, 5, 8, 11, 14, 17, and 20. If we were to calculate the arithmetic mean of 2 and 20, it's going to give us the number right in the middle of 2 and 20. So the arithmetic mean is going to be the sum, which is 2 plus 20 divided by 2. 2 plus 20 is 22, and 22 divided by 2 is 11, which is the arithmetic mean. Now let's say if we want to calculate the arithmetic mean between 8 and 20. The number that's right in between 8 and 20 is 14. So that's what we should get. So if we average 8 and 20, if we add them up and divide by 2, that's 28 over 2. That's equal to 14. Now let's try one more example. Let's find the arithmetic mean of 5 and 11. That should give us a number in between 5 and 11. So if we add 5 plus 11 and divide by 2, that's 16 over 2, which is 8. So hopefully these examples will now help you to understand what is meant by the arithmetic mean. The arithmetic mean of two numbers is simply the number in between those two numbers if you were to write out the arithmetic sequence. Now the same is true for a geometric sequence. So let's say the first term is 3 and the common ratio is 2. 3 times 2 is 6, 6 times 2 is 12, and then we have 24, 48, 96, and 96 times 2 is 192. So let's calculate the the geometric mean between 3 and 192. It should give us the number in the middle, which is 24. So the square root of 3 times 192. Let's multiply 3 times 192 first. That's 576. The square root of 576 is 24. So 24 is the geometric mean of 3 and 192. It's right between those two numbers. Now let's calculate the geometric mean of 6 and 24. That should equal 12. 6 times 24 is 144, and the square root of 144 is indeed 12. For the sake of practice, let's do one more example. Let's calculate the geometric mean of 12 and 192. That should give us a number in the middle, which is 48. So 12 times 192 is 2,304. The square root of that number is indeed 48. And so that's it.